In this video, I'm going to talk about quartiles. So quartiles are special percentiles, and they basically divide the data into four parts. So the first quartile, which they call Q1, is the 25th percentile. The second quartile, which also happens to be the median, which they're going to refer to as M, is the 50th percentile. The third quartile, Q3, is the 75th percentile. So to find the quartiles, we need to order the data from smallest to largest. We'll find the median, which is in the middle. And then to find Q1, it's the median of the bottom half of the data. And to find Q3, that's the median for the top half of the data. So let's go ahead and look at this example here. We're being asked to find the quartiles, and I notice that the data is not in order. So I'm going to go ahead and put it in order. So one is going to be that one, but I have another one here at the end. So there we go. We have two ones. We have a 2 here and a 2 here. 4 looks like is next. No 5s. 6 though. 6.8. 7.2. 8 looks like it's next. 8.3, 9, and 10 twice, and 11.5. All right, there we go. So our data's in order. And let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 pieces of data. 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, nope, sorry, 14 pieces of data. Wow. Okay, so 14 total. Write that down. Okay, so halfway then is going to be, actually, it's an even number, so it's going to be between two values. So let's see. Let's find the halfway point. 1, 2, 3, 4, 5, 6, 7. Okay, so here's the halfway mark. So between 6.8 and 7.2, 6.8, 7.2, divide that by 2, that actually comes out to 7. Nifty. So there's M, which is technically the second quartile. So we found that. Okay, to find Q1, I'm going to look at the first half of the data here. So I'm basically just going to focus in on this data right here. And since there's 7 pieces of data, I'm going to find the middle. So 1, 2, 3. So it looks like right here in the middle then is 2. So that's going to be Q1. That doesn't look like a 1. There we go. Q1 is 2. All right, repeat that process for the second part of the data here. So since there's 7 pieces of data, I'm going to go ahead and count 1, 2, 3. So that is going to be the middle. So 9 is Q3. All right, the interquartile range. So the interquartile range is the difference between Q3 and Q1. It is the middle 50% of the data. So it's literally representing 50% of the data, but it's in the middle, okay? But the IQR is useful because it allows us to look at outliers. So we can find an outlier if it happens to be lower or higher than these kind of cutoff marks, which we call the fences. So the lower fence is Q1 minus 1.5 times the IQR, and the upper fence is Q3 plus 1.5 times the IQR. So 1.5 always stays the same. And anything that is smaller than the lower fence, a value that is smaller than the lower fence is going to be an outlier. And a value that is bigger than the upper fence is going to be an outlier. All right. And outliers are really frustrating because they can really mess with our data. So let's look at an example here. And they want us to see if we have any potential outliers. So I'm going to need to find all the, the quartiles. And that means I'm going to need to put it in order because it isn't in order. All right. So let's see. Smallest data value, 158, 114. Okay, there we go. So it looks like I'm going to try to give myself enough space. 114950. Then it looks like it's going to be 158,000 after that. Okay. 230,000 after that. Okay. Okay, so 387,000 first. So we have two of them in the 300,000s. And then 389,000. Oh, sorry. 9,950. Second. All right. 1, 2, 3, 4, 5. So I'll go two more and then I'll go to the next line because I'm definitely not going to have enough space. Wow, that's like a terrible comma. Let me fix it. There we go. All right. Not that much better. So 479,000 looks like it's next. Two 400,000s. Okay. And then 488,800 after that. All right. So then I'm going to go to the next row here just for space. So I'll have 529,000 first. And then it looks like 575,000 next. 639,000. 659,000. We finally jumped to the millions here. So first one is 1,095,000. And last one is 5,500,000, which is pretty big compared to the rest of the data. Makes me suspicious that that might be an outlier. Let's verify it and see. Okay, so because I kind of split the data up, the top 7 are the first 7 pieces of data and the bottom are the last 6. That means since there's 13, the middle is going to be this number right here. So that is my median. I'll just go ahead and identify it because, hey, I found it. All right, so Q1 is going to be in the middle of the top half up here. So 1, 2, 3, 4, 5, 6. So it's going to be in between these two, right? In between those two values right there. So I'm going to add those two together. 230,000, oops, 500 plus 387,000 divided by 2. Let's see, that'll come out to 308,750. Okay, so there's Q1. Q3, similarly, we're going to be between these two values down here, right in between them. So that's 639,000 plus 659,000 divided by 2. And that comes out to 649,000. Duh, I could have seen that if I had been paying enough attention. Okay, there we go. There's Q1, there's Q3. So now that I have that, I can find IQR. Definitely running out of space here. So IQR is going to be the difference between those. Here, let me do that over here see if I can squeeze the fences down here at the bottom. So IQR is the difference between those. So if I subtract 649,000 minus 308,750, that's going to give me 340,250. Okay, there we go. There's my IQR. Okay, so now that I got that, I'm going to calculate the fences. And I'm going to go ahead and do that in blue just because I am squeezing so much in here. So the lower fence is Q1, which was this number right here, 308,750 minus 1.5 times 340,250. All right, so let's plug that into the calculator. And that comes out to negative 201,625. Okay, it's okay that the fence comes up negative because this is not necessarily referring to a data value. It's just saying that anything that's lower than this number is an outlier. What that means is in this data, there is never going to be a low end outlier. Okay, based on this data, there's no number small enough to be an outlier just based on where all the numbers are grouped up. But it is possible for there to be an upper outlier. So for that one, we take Q3, 649, and add 1.5 times 340,250. And that comes out to 1,159,375. All right. So our last data value is bigger than that number, which means our last data value is an outlier. 5,500,000 is an outlier. All right, cool. Squeezed it all in. Let's look at the next example here. So for this one, they have given us data and they've given us the relative frequency. So this is amount of sleep per school night. And then the cumulative relative frequency. So remember, cumulative relative frequency, they're adding up each category previous to that category. So the 14 here, the 0.14, is saying that 14% of people sleep 5 hours per night or less. Okay, so we're referring to that. So over here, when it says 0.8 means 80% of people sleep 8 hours or less. All right, based on this data. So all of those before it. Okay, and plus they gave us the frequency, and this is going to help us calculate these percentiles without really needing to put it all in order, because I really don't want to write this all out. I could. In other words, if I were to write this all out, since 2 people said they'd get 4 hours of sleep, the first 2 data values would be 4. And then the next 2 data values, the next 5 data values is going to be 5. And then 6 will be 7 of them. Right? Okay. And so forth. You keep going, but I don't really want to write this out. I'm going to use reasoning to kind of do this. And based on the information they gave me, they kind of asked me some specific ones. So I might be able to figure this out. Okay. So they want me to find the 28th percentile. Well, I look over here and I see that in the cumulative relative frequency, 28% of the data is 6 hours of sleep or less. So for the 28th percentile, remember the percentile is that it could be that number or less than that number, okay? So it could be the value of that number. And often for that reason, we are going to say that the actual number that represents the 28th percentile is going to be a little bit bigger than this. In other words, it would be between the next 2 categories, the 6 and the 7. So between the 6 and the 7, that would be 6.5 hours. Now, I think there's an argument to be made to say that simply the 6 hours represents the 28th percentile because 28% of the data is represented as 6 or less. All right. But some people will argue that 6.5 is necessary to say that the or less part of that it's literally less than 6.5 hours. Okay, let's look for the median. Now, the median in this case is going to be in the middle of this, and we have 50 students. So the median is going to be between the 25th and the 26th data value. I'm going to write that down, 25th to 26th data value. Okay, and I happen to see too that this is marking 52%. Okay, so 52% of the data happens there. So I'm kind of thinking like we have to go prior to that. And if I look at the frequency, and I'm kind of adding this up, so this is 7 pieces of data, 14 pieces of data, 26 pieces of data. So this is representing 26 pieces of data right here. that means that the 25th and 26th data values are both sevens, because 12 people answered 7, as there are a number of hours per sleep. So this means that the 7 represents what the 25th person said, and 7 represents what the 26th data value is. Therefore, the median is 7 if you average those out. Okay, third quartile. So now we're looking at the 75th percentile. And I'm looking over here at the cumulative relative frequency, and I see that 80% fall into this category, which also happens to be the biggest category. So there's 14 people who said 8. And since 52% is all the way back for the previous category, it's very safe to say that the 75th percentile is going to happen among these 14 data values. So the third quartile is going to be 8.